Hello, today what we're going to do is finish up our instruction on the laws of exponents. And so we have one more, actually two more laws to go, but they both deal with division. So we're going to continue simplifying monomials, but this time using division and quotient laws of exponents. So just as normal, what we're going to do is go over the prior knowledge that we must have in order to be successful with the new information that we're going over. So we're continuing with laws of exponents. The title of this section is Division and Quotient Rules. So the prior knowledge we need basically is all the other laws of exponents. So we have to remember the law about zero exponents. Anything to the 0 power is 1. We need to remember the laws about negative exponents. If you have a negative exponent at the top, it moves to the bottom, the exponent becomes positive. If you have a negative exponent at the bottom, the number moves to the top and the exponent becomes positive. We need to remember the laws that deal with multiplication. So if you're multiplying two numbers that have the same base, you keep the base, add the exponents. We have to remember the law about raising a power to a power. If you raise a power to a power, you keep the base and multiply the exponents. What's really tricky is making sure you know the difference between these two laws. So you have to be very, very careful when working with them. And then the last one that we covered was the product to a power law. If you raise a bunch of bases to a power, the power applies to each base. So all of those other laws we have to recall in order to be successful with the next two. So we're going to now get into new material, and the first new law that we're going to discuss is the law of exponents dealing with division. So the law of exponents dealing with division reads, if you divide two numbers that have the same base, you're dividing two numbers that have the same base, keep the base, subtract the exponents. So we would keep the base, subtract the exponents. Top minus bottom. Okay, so that's how the exponents would work. Keep the base, subtract the exponents, top minus bottom. So if I'm dividing the same base, I keep the base, I subtract the exponents. I can also look at this in canceling things. So the other way I say to talk about using the law of exponents with division is cancel stuff. You can do things that way. So let's start with a basic example. If we were to simplify the expression x to the third over x to the 10th, we can use the law of exponents the way it's reading, where you keep the base, subtract the exponents, or you can look at this example in the way I do is cancel stuff. So we're going to go over how each of that looks with this example. So in the first way, we have our law, okay, the law of exponents. If you're dividing two numbers that have the same base, keep the base, subtract the exponents. So in this example, we're looking at x to the third over x to the 10th, keeping the x, subtracting 3 minus 10. And so we have x to the 3 minus 10 power, which of course is x to the negative 7th. So we can start with that, but we have to remember x to the negative 7th brings us to a different law of exponents. We have the negative exponent. So if we had x to the negative 7th, we have to remember that we have the law about negative exponents, and then knowing that x to the negative 7 is 1 over x to the positive 7. So there's that way of looking at the example if you're using strictly the law of exponents, keeping the base, subtracting the exponents. But we can also look at it with canceling stuff. And this is the way that I look at it. Look at it with canceling. Either way is fine as long as you're doing it correct. So we have the same example, x to the third over x to the 10th. Let's look at it in the way of canceling things. So if I have x to the third power, which we all know is x times x times x, At the bottom, we had x to the 10th power, which we all know is x times itself 10 times. Canceling stuff. If you have the same thing on the top of a fraction as it is on the bottom of the fraction, we know by now you can cancel it. If something on the numerator is the same as the denominator, that equals 1, so it can be canceled. You can cancel one of these, two of these, three of these. And so you have to think, all right, well, what's going to be left after I do all that? At the top, what's going to be left is simply the number 1. Everything at the top cancels, leaving you with 1. At the bottom, you're left with all of those x's. 1, 2, 3, 4, 5, 6, 7 x's. And so if you're left with 7 x's times itself, that is, by definition, x to the 7th power. So you can look at things in the way of using the law of exponents, or you can look at things in the way of canceling. So I know this might be a little bit confusing. So we'll do a few examples, okay? Hopefully by the time we finish, it'll be a lot easier. So in the first example, if I had the expression that we're going to simplify a to the 12th over a to the 4th, we can look at this example in the way of using the law of exponents. If you're going to use the law of exponents, the law reads, if you divide two numbers with the same base, keep the base, subtract the exponents. That's what the law reads. So we could use that method with this example. You have a to the 12th divided by a to the 4th. Keep your a, subtract your exponents. 12 minus 4. And since 12 minus 4 is 8, you could have a to the 8th power. So you can look at it that way. You can also look at this example in the way of canceling. Which again, I'm more comfortable with it. It's all a matter of what you're comfortable, what's going on with your brain. So in the same example, if you have a to the 12th over a to the 4th, you can think in terms of this in canceling. So we have 12 a's at the top. There's 5, 6, 7, 8, 9, 10, 11, 12. Just enough left on my paper. There's 4 a's at the bottom. I almost wrote the number 4. So you have a to the 12th, a times a to the 4th, a times a times a. So you have the top and the bottom. You can think in terms of canceling. So let's cancel what we can. What's the same on top is the same on the bottom. I can cancel 1 of them, I can cancel 2 of them, I can cancel 3 of them, and I can cancel 4 of them. So I've canceled 4 of them out. What is going to be left? Well, let's count what I have left. We have 1, 2, 3, 4, 5, 6, 7, 8. There's a to the 8th power that's left. So I can look at it in canceling. Either way works, okay? Either way is going to work, but whichever way you can do it correctly, that's what we're going to work with. All right, so we're going to do one example with this particular law of exponents that gets a little crazy, and then we'll get to the next law. So here's the next example. It's going to look a little crazy. What if we had 10 x to the 4th power, y to the 3rd power, all that over 2x squared y. Okay, so if you want to look at this example with the law of exponents, you have to remember something about fractions and how they relate with multiplying. So let's look at this in the way of law of exponents. And the law states, if you divide two numbers that have the same base, you keep the base, subtract the exponents. So let's do that. But if you're going to do that, you have to remember that what you're looking at in this example, what you're looking at is something kind of funky. You're looking at this fraction, 10 over 2. That's being multiplied by this fraction, x to the 4th over x squared. Keeping the numbers that have the same base lined up. And that's being multiplied by y to the 3rd over y, by that fraction. So you have to remember how the multiplication of fractions works, so you can then split this up into all of the bases that have the same thing. Number over number, you have your x over your x, you have your y over your y, and knowing that it's all multiplication taking place. And so with each little thing that you have set up, you can now use that law of exponents. So the first thing we're looking at is the 10 divided by 2, which of course is 5. And then you have x to the 4th over x squared, which according to the law of exponents means we keep the base, subtract the exponents, and then we have the y to the 3rd over y. Once again, keeping the base, subtracting the exponents. 3 minus what? What's the, if you remember what the exponent is for this y. 3 minus that exponent, of course, is our friend the ninja. 1. You may not see him, but he is there. Or she. So we've applied the law of exponents that way. And now we continue to simplify. So we have 5 times x to the 2nd power times y to the 2nd power. And then to make it look professional, smush it all together. 5x squared y squared. And that's how it looks nice and professional. So there is this example using the law of exponents the way it's written. But I'm going to do the same example thinking about canceling now. So we're going to think about canceling. Remembering how canceling works in those previous 2 examples, so we're going to do the same thing here. We're looking at what's going to cancel from the top and the bottom. Okay? So here's how we work with canceling. At the top we have a 10, at the bottom we have a 2. So how many times does 2 go into 10? 5 times. The 2 cancels completely, the 10 cancels, and it leaves us, again, with how many times is 2 into 10? 5 times. It leaves us with the number 5. You have an x to the 4th at the top and an x squared at the bottom. If you picture all of the x's being lined up, you're picturing that in your head, and all the x's that cancel out, you're going to be left with x to the 2nd power at the top. Okay, so all of those x's canceling out leaves you 2 x's at the top. And looking at y to the 3rd over y, picturing all the y's written out from the top and bottom and canceling things out, you're going to be left with 2 y's at the top. So you can think of this in terms of canceling. And what's going to be left? 5x squared, y squared, all at the top. 5x squared, y squared, all at the top. So you can think in terms of division with canceling. I find that a little bit easier. We'll see more of that in a second, but first I want to pause here and get into the next law of exponents. So the next law of exponents that we're dealing with has to do with raising a quotient to a power, which is very similar to raising a product to a power. Just knowing that if you have a group of things being raised to a power, that exponent gets applied to each thing. Okay, so if you have this being raised to power, the exponent goes to the top, the exponent goes to the bottom. So it gets a lot more complicated, as you'll see. So the words that I've written out for this, the quotient, if the quotient of 2 bases, remember division means quotient, if the quotient of 2 bases is being raised to a power, the exponents can be applied to both the top and the bottom. Okay, so that's how this law works. It's very similar to product to a power, but this is dealing with division. So let's take a look at a basic example. So let's say we have this expression that we want to simplify. We have a fraction being raised to a power. We have a quotient being raised to a power. So how does this work? We apply the exponent. We apply this exponent of 3 to both the top part of the fraction and the bottom part of the fraction. Hopefully what you're seeing is that, hey, we're going to have to do another law of exponents from a while ago. Yes, we will, but if you don't see that yet, you will see it soon. So we're first going to use the law of exponents that states if you have a quotient to a power, you apply the power to the top and the bottom. So we're first going to see how that looks. That means we take our expression and we apply the 3 to the top and we apply the 3 to the bottom. Okay, so we're just taking that exponent and applying it to the top and the bottom. So we have this expression now. And so now we have x to the 4th to the 3rd power over 3 to the 3rd power, and we'll use other laws of exponents to simplify that. So do you remember what happens with that x to the 4th to the 3rd power? We're going to use a law. We're going to use our old law that says if you raise a power to a power, keep the base, multiply the exponents. So we keep the x and multiply the 4 times 3. At the bottom, 3 to the 3rd power. And then we multiply 4 times 3 to 12. We have 12 over x to the 12th over 3 to the 3rd power, which we can evaluate. 3 to the 3rd power is 3 times 3 times 3. So you can evaluate that. You'll be left with x to the 12th over 27. So that's how that quotient rule works. If you raise a quotient to a power, the exponent is applied to the top and to the bottom. And that's all of the laws of exponents. So what we're going to do are a few examples that showcase everything. So let's do a few examples that showcase everything. Here's an example. This is one of my favorites because I always find it neat. Let's say we take this quotient and raise it to a power of -3. Okay? So we take this quotient, raise it to a power of -3. According to the law of exponents, the law states if you raise a quotient to a power, that power can be applied to the bases on the top and the bases on the bottom. So we're going to take that m to the -3 and we're going to apply the -3 to each of the bases. The base at the top and the base at the bottom. Okay, so we followed that law. So this law we have followed strictly. Okay, the -3 gets applied to the m, the -3 gets applied to the n. We follow that law strictly. And now, what's going to happen? What's going to happen is we have to use the law of exponents that deals now with negative exponents. We have negative exponents that we can't be comfortable with. So we have the laws of exponents that deal with if you have a number to the negative power, it moves to the bottom and becomes positive. If you have the number with a negative power at the bottom, it moves to the top and the power becomes positive. So we can apply both of these things to this situation, and let's see what's going to happen. What's going to happen is that they end up flipping. This number has to move to the top, so the exponent can become positive. This number has to move to the bottom, so that the exponent can become positive. Okay, so we're going to move the exponent from the bottom up to the top. We'll now have n to the +3 at the top. And the m to the -3 moves down, and we're going to have m to the +3 at the bottom. So we've kind of done a flip-flop in this case, which is why I like this problem. But we kind of flip-flop so the exponents can become positive. And that's how that example works. That's a basic problem that deals with the quotient rule. But normally when you deal with the quotient law of exponents, you'll have to use other laws. That's normally going to happen. So, now that we know all the laws, what's going to start happening is that you will find infinitely many ways to do this correctly. So for each example that I give, the one way that I do it is not the only way it can be done. Okay, there's methods that I use that you don't have to use. You'll get to the same result, but you don't have to use the same path. So let's do an example. Let's say we have something really tricky, like 3x squared over 5y to the 4th, but we have it raised to the -4 power. Now there's a million things that we can do with this to get it correctly. But the first thing I'm going to do is use that latest law that we used, and the latest law is quotient to a power. I'm going to use that law first, that if I have something big being raised to a power, the power gets applied to both the top and the bottom. I'm going to do that first. So I'm going to end up with 3x squared, just this top part, and that part raised to the negative 4. The fraction bar is still there, and then I have this entire bottom raised to the negative 4. Look how careful I am being with my parentheses, because it's going to make a big difference because the next thing I'm about to do. So what I've done right now is apply this law to this to get this. The next thing I'm going to do is apply the law that deals with raising a product to a power. So I'm going to work with this law now. If I have a product that I raise to a power, the exponent gets applied to each base. So from this point, if I have this product being raised to the negative 4, I'm going to apply that negative 4 exponent to everything inside. I'll have 3 to the negative 4. I'll have x squared to the negative 4. At the bottom, I'll have 5 to the negative 4, and I'll have y to the 4th to the negative 4. So I'm applying that law to everything. So I'm taking this expression, applying this law to this expression to end up with this. And now the next thing I'm going to do is use the law of exponents that deals with raising a power to a power. Remembering that if I had a to the n power, raise that to a power, I keep the base, multiply the exponents, I'm now going to apply that to this expression, what's going to be left. So I'll still have 3 to the negative 4 power here, but I'll have x to the second power to the 4th power. That means I'm multiplying those two. According to this law, I'm multiplying those two. 2 times negative 4 is negative 8. At the bottom, my 5 to the negative 4 stays there. But here, once again, I have a power to a power. I keep the base. I'm going to multiply the powers. So I have y to the negative 16th. So at the bottom, 5 to the negative 4, and then y to the negative 16th. So that's where I'm at for now. I'm almost done, because now what I have to do is use the law of negative exponents. So my law of negative exponents says that this is going to move to the bottom, this is going to move to the bottom, this is going to move to the top, and this is going to move to the top. So I'm basically doing the old switcheroo again. So what I'll end up with is this 5 to the negative 4th getting moved to the top, so the exponent can become positive. I have the y to the negative 16th moving to the top, so the exponent can become positive. All those things that I had at the top are now going to be at the bottom. 3 to the negative 4 moves to the bottom, so the exponent can be positive. And x to the negative 8 moves to the bottom, so the exponent can be positive. And so that's where I'm at for now. So I've used all of these laws. It's like these crazy sets of laws that are going. Now all I have to do is evaluate what I can. Can I evaluate 5 to the 4th power? Yes, I can. Can I evaluate 3 to the 4th power? Yes, I can. 5 to the 4th power is, of course, 5 times 5 times 5 times 5, which gives me 25 times 25, which is 625. So I know I have 625. My y to the 16th stays there. At the bottom, 3 to the 4th power is 3 times 3 times 3 times 3, which is 9 times 9, which is 81. And my x to the 8th power stays there. The bell is about to ring, so if the bell rings, we're going to keep on trucking. I have one more example to give. So again, if the bell rings, ignore it. It's on the video. So let's do one more example. It's a crazy one. It's a crazy one. But this is what things are going to look like on the test, because we have to know the laws of exponents. Also because it's fun. These things are so much fun. So we have 2 times a to the negative 1 power times b to the 6th times c to the negative 3rd. All that is over 14. A to the 5th. B to the negative 1. C to the 5th. So there's lots of things that we can do. There's so many things that we can do with this. It's infinitely many ways. What I'm going to do first, I'm going to deal with negative exponents first. That's the first thing I'm going to deal with. The negative exponents. That means if they're on the bottom, I move them to the top. If they're on the top, I move them to the bottom. So that's what I'm going to deal with first. So here's our example. The 2 stays, the a moves. And if the a moves, it's going to go from the top to the bottom, and the exponent becomes positive. The b stays, the c moves. It has a negative exponent. So it's going to move to the bottom and make that exponent positive. On the bottom, the 14 stays, the a stays, the b has a negative exponent. So this is going to move now to the top. And the c stays put. So all of these moves are going to happen. So the 2 stays at the top. The a to the negative 1 is no longer there. The b to the 6th stays at the top. The c to the negative 3rd is no longer there. But the top is going to be joined by this little thing at the bottom. It's going to move to the top and become positive. So we're going to have b to now the positive 1 joins in at the top. And there's our top. At the bottom, the 14 stays. The a to the 5th stays. The b to the negative 1 moved already. And the c to the 5th stays. But that's not it for the bottom, because we have things coming down from the top. So now we have that a to the positive 1 now, and then c to the positive 3. There's the bell we're going to ignore. I'm almost done. So after all the moves take place, this is what we have. So now what we're going to use is the multiplication law. That if you're multiplying 2 numbers that have the same base, keep the base, add the exponents. At the top, the 2 stays there. B to the 6th times b to the 1 is b to the 7th. Keep the base, add the exponents. At the bottom, the 14 stays there. But we have a to the 5th times a to the 1st. A to the 5th times a to the 1st. That gives us a to the 6th. And then we have c to the 5th times c to the 3rd. Keep the base, add the exponents. So I have this now. The only other thing left to do is simplify my constants. I have a 2 at the top, a 14 at the bottom. We can use cancellation. So that cancellation thing that we talked about earlier can be applied here. So the cancellation piece can be applied here. Can 2 go into 14? Yes, it can. 2 goes into 14 7 times. That means the 2 cancels completely from the top, and the 14 cancels, but is left with a 7 at the bottom. So what's left? We have b to the 7th at the top, over at the bottom, 7, a to the 6th, c to the 8th. So we have all of these laws of exponents in place. I'll just show you one last example that goes quickly because it's one of my favorites. One of them. So here's an example. Look at all that craziness that's going on here. I mean, look at all these laws that we would have to use to simplify this. It would be so crazy to work this out, then all of a sudden you notice, what is that? Is that a 0? That's a 0. If that's a 0, we only have one law to work with. if that's a 0, we're only working with anything to the 0th power is 1. This whole thing shakes out to be 1. One of my favorites. So that's it for all the laws of exponents for the notes. The rest is practice and get ready for the test. I hope you learned something new, and then we'll move on from here. So good luck with everything.